Hi children, welcome back. This time I've come up with a physics topic called force and pressure. Force is a push or a pull acting on a body. I'll demonstrate this with an example. I pull the door towards me and I push the door away from me. This push or pull that I applied on the door is called force, and the direction in which the object, that is here the door, is pushed or pulled is called the direction of the force. Now, what is the unit of force? The SI unit of force is Newton. A force that can make a body of mass 1 kg move at a speed of 1 meters per second is called 1 Newton. Next, the effects of force. Number 1. Force can move a stationary object. To give you an example, during a penalty kick, the football is first at rest. When the player kicks the football, he applies force to the football and the football moves towards the goal post. Second, force can stop a moving object. To give you an example, when a player stops a football that is passed on to him, he is stopping the object, that is the football, that was initially moving. The third, force can change the speed of a moving object. When a person pushes a moving bicycle from behind, then the speed of the bicycle increases, and if the person pulls the moving bicycle from behind, then the speed of the bicycle decreases. Force can change the direction of a moving object. That's number 4. Example, when a bowler bowls to the batsman, then the batsman hits the ball with a bat and changes the direction of the moving ball. The fifth and the last, force can change the shape and size of an object. When you press a soft ball with your hand, what happens is the shape and size of the soft ball changes. This is the glimpse of what we have done till now. Forces are of 2 types, contact forces and non-contact forces. Now what are contact forces? Contact forces are those forces that come into action when the 2 objects are in actual contact with each other. That is, the objects physically touch each other. There are 2 types of contact forces, muscular force and frictional force. The force exerted by the muscles of the animals and human beings are known as the muscular force. For example, when a player kicks the football, then the force that is exerted by the muscles of the player's legs is the muscular force. I also gave you an example in the beginning that when I opened and closed the door, that is when I pulled and pushed the door, I was using my muscular force. The second is the frictional force. Frictional force is the force that opposes motion when the 2 things come in contact with each other. I'll give you an example. When we are cycling and if we stop paddling, then gradually the cycle slows down and comes to rest. This is because when the cycle tire and the road are in contact with each other, the frictional force is acting on it, and so the cycle comes to a stop. The other type of force is non-contact force. They are of 3 types: magnetic force, gravitational force, and electrostatic force. Now what is magnetic force? When we bring a magnet near things made of iron, nickel, or cobalt, then the things get attracted to the magnet and stick to it. Here, the magnet is not in contact with the iron things, but at a certain distance away from it, and still it exerts a force. So this is an example of non-contact force. Gravitational force. The force with which the earth attracts the objects towards it and causes them to fall towards the earth is called gravitational force, or simply gravity. For this force to act, the earth and the object are not in contact with each other, so it is also an example of non-contact force. Next is electrostatic force. The force exerted by electrically charged object is called electrostatic force. It can be either attractive or repulsive depending on the charge of the other object. Here too, the 2 objects are not in contact with each other, so it is an example of non-contact force. To give an example, you might be aware that when you rub a comb across your dry hair, and then bring it near small bits of paper, then they get attracted towards it. This is due to electrostatic force. The next topic is pressure. Pressure is force exerted per unit area. So what is the unit of pressure? The SI unit of pressure is Newton per meter square, because P is F upon A, force is measured in Newton and area is measured in meter square. This unit, Newton per meter square, is also known as Pascal in honor of the scientist Blaise Pascal, who has devised many laws of pressure. Now for understanding pressure, I've taken two examples. What do you think would be the pressure exerted by an elephant on the earth and a lady who has worn a high-heeled sandals on the earth? Surely you would always tell me that an elephant would exert more pressure, but there you are wrong. I'll demonstrate it. Now suppose the mass of the elephant is 4,800 kgs. So the force exerted by the elephant is ma, that is mass into acceleration due to gravity. So 4800 into 9.8. For our calculations to be made simple, let us take it as 10. So the force exerted by the elephant is 48,000 newtons. On the other hand, the lady with high-heeled shoes or sandals has a mass of, let's say, 65 kg. So the force exerted by the lady on the earth is 65 into 9.8. That is 650 newtons. Now the area of one leg of an elephant is around 0.04 meters square approximately, and the area of one heel of the sandal is 0.0001 meters square. Now area of four legs of the elephant is 4 into 0.04, that is 0.16 meters square, and the area of two heels is 2 into 0.0001, that is 0.0002 meters square. Now in case of elephant, pressure is force upon area, so 48,000 upon 0.16, that is 300,000 kilograms per meter square. That is the pressure exerted by the elephant. On the other hand, the pressure exerted by the two heels is 650 upon 0.0002, that is 3,250,000 kilograms per meter square, or you can also call it as pascals. So this goes to show that 300,000 pascals is way less than 3,250,000 pascals exerted by the lady because of the high-heeled sandals that she is wearing. You can also understand pressure by this example. When you hit the hammer onto this nail, the area of the nail in contact with the wall is very less, so it will immediately get pierced into the wall. On the other hand, if you try to pierce this nail over here, where the area of contact with the wall is way too much than over here, so this hammer will not be able to pierce this nail into this wall. A couple of important aspects about pressure. Pressure exerted by a liquid depends on the height of the liquid column above it. That is, as you go deeper, the pressure increases. This can very well be demonstrated by the experiment that I've drawn on the next page. As you can see over here, there's a bottle where there are 3 holes at different heights. The hole number A at a height, the hole number B at a lesser height, and the hole number C at still a lesser height at the bottom of the bottle. Now when you allow these holes to allow water to flow through them, what you see is there is very little water above hole A, only this much column of water. Above hole B, there is this much column of water. Above hole C, there's a whole lot of water column above it. So the water gushing out from hole C will go at the maximum distance because of the high pressure at which the water gushes out. From hole B it would, but not as much as C, and the water gushing out from the hole A would fall almost near to the bottle. This is also the reason why the dam walls, when they are built, they are very broad at the bottom. So as the level of the water increases, that is, as the depth increases, there is more pressure exerted at the bottom of the dam wall. The second is liquids and gases exert pressure equally in all directions. For example, when you fill a ball with air or water, then the air or water inside the balloon exerts pressure equally all throughout the inner surface of the balloon as shown below. Thank you. I hope it was useful in understanding force and pressure.